Hi, everybody. My name's David. I'm a PhD student at the IT University of Copenhagen. And before I talk about pretty printers and programming and all that stuff, I want to tell you a story about an ancient, legendary time from before I was really involved with computing at all. And I wasn't there to see it, but I've heard stories about this legendary time, which is called the early 90s. Back then, they had these really advanced user interfaces that looked like this. And on these systems, you could sort of type in commands, and it would sort of read what you'd typed, eval it, and then print a result. So you could type in defun addition xy is plus xy, and it gives you back the result addition, which is the thing that you've just defined. And that's pretty cool. I mean, we can do similar stuff in GHCI. Yeah. Yeah, but what's really special at this time in the early 90s is you could put your mouse over the word addition and it would kind of light up and say, something's going on here. You could then right-click on it and a list of commands related to addition actually would appear. So I could, for example, say, show this function's argument list, and indeed we get back that the arguments to addition were x and y, and that's kind of cool. We can't do that in GHCI. There's no mouse support in the console yet. Late 70s. Yeah. I think they put this feature in like 92, but I'm not entirely sure. This is from a symbolics list machine. So then I can go back to addition, and I can right-click again, and I can say describe addition, right? Because you might suspect that when I'm right-clicking on something, there's something going and parsing it and saying addition and blah blah blah. But that's actually not what's happening. So I get back out this report, and this report contains some sub-objects, and those sub-objects are actually linked sort of to pointers to the actual thing they represent. So it's got all this garbage about it, and if I go over this particular part of the definition environment of addition, it also lights up, and I can I can continue doing this until I feel sick to my stomach. So I think this is a really powerful idea in user interfaces to interactive top levels like GHCI, and it's one that unfortunately seems to have died after symbolics went belly up. They were working on reinventing it for Dylan, but aside from that, I haven't really seen it. And the word they used for this concept was presentations, which is to say you have a connection between output on the screen and the underlying object that's actually represented by that output without actually needing to go and do something horrible like run a parser and deal with ambiguity and all that kind of stuff. So that's for editing source code, and this is for output from the compiler. So the IntelliSense is making very good work of understanding what users are typing, but it doesn't really help you when the compiler comes back and says what you typed was wrong and here's why. So I think that we can't quite do it today the way that they used to in that legendary time of the early 90s. Because programming languages can't really take over the world like they used to be able to. I mean, the small talk people are fighting the good fight, but these days, we really expect to be able to access our compilers and our tools through a variety of interfaces. We want, a console like current GHCI. We want web interfaces. We want, text editors, both the classical editors like Emacs and Vim, and these whippersnappers like Atom and Sublime. And we also want to be able to support things that the original language implementers didn't even think of, like IRC bots, search engines, things like Hoogle. And all the unknown products of human ingenuity that have not yet been made and that will not be made if we don't make it possible. So what this talk is actually about is how this presentation concept was implemented in Idris, and that there's sort of the authorial way I did it. And I want to pose the question to all of you, can Haskell and specifically GHC make use of the same technique in a productive way? I think so, and I hope so, and it would be really cool if it happens. So for those who don't know, Idris is a pure functional language that I think of as being sort of part of the broad Haskell family of languages. It looks a lot like Haskell. It's got type classes, it's got do notation, it's got monadic I/O, it's got layout syntax. It's strict, but other than that. And also it has full dependent types. Just a little thing. It's primarily developed by Edwin Brady at St. Andrews, but we have contributors from all over the world, such as myself. And it's written in Haskell, so there's a real strong personal interest in having even better Haskell development tools than we have today. So that's what Idris is, but what is it like? How is it to use these days? Well, Here's a little demo. So if I start up Idris, I get this prompt. It'll look very familiar to users of GHCI. I can use it as a desktop calculator. I can say 3 plus 3, and I get back that it's an integer.
Something code.
Oh no.
It's all right, Idris, you only care about the types.
You seem to have mistaken me for an Agda developer. That doesn't look as cool as the full screen, but at least it should be readable. Okay. So another thing I can do is I can say, concat the list consisting of A and B. And I get back A, B, just as we'd expect. And that's all well and good. So this is how Idris was for a long time. And then I went to a really cool demo by Julia developer where they had all these really pretty console colors. And I thought, I want that. It really helps to understand code when the compiler gives you some hints as to what things are. So I turn on my color. And now when I add 3 to 3, I get back a little red 6 and a little blue integer. Because 6 is kind of data, and integer is a type, and when we mix these things together, it's really easy to get kind of confused and dizzy, and the colors help make sense of that. Yes. So it's actually totally themable, but he uses the McBride colors by default because Edwin's friends with it. And then if I ask for the type of, say, concat a sometimes I think I should bring my kinesis and plug it in when I'm doing talks because I'll type much faster. So now we see that concat is green and all of that. And this sort of signifies to the reader that computation may occur, right? So I think an analog in GHC's output might be a type synonym versus an actually defined data type, where the type synonym may actually be expanded, or a type family or something like that. And it gives some nice hints to the reader. And this is all well and good, but who likes to hang out in terminals? We have much better OSs than that. And so if I'm in my preferred OS, I can open my Idris REPL and I can say 3 plus 3, and I get back that 6 is an integer. I can say, ask for the type of concat A, B, and I get back this. And that's pretty nice. Then I can move the mouse over my B here, and I get a little tooltip. Unfortunately, I couldn't figure out how to make the GTK theme show stuff readable in the back of the room, but this tooltip says that B is a string, and it's a string of length 1. If I put the mouse over concat, I get that it's prelude.foldable.concat, and that's got foldable T, monoid A, T of A to A. And it's got a little first sentence of the doc string there. This is quite nice. I've even got it on the prompt there. And then I can right-click on concat, and I can say, well, give me the full doc string for that, and it pops up in a separate buffer. I can right-click on concat again, and I can say, give me the definition. And we get back that it's this definition right here. I can right-click on anywhere in this term here, including over concat or in the space, and then I can say normalize it. And it gets normalized right in place in the middle of the REPL. I can then say undo, and I can right-click it, and I can say show me all of the implicit arguments. So there's a lot of hidden things behind the scenes that happen, like type class resolution and figuring out that A here is string and that T is list. And if I want to know what actually happened, say I'm trying to debug some complicated code, then I may want to see this representation. Normally I don't want to see this representation. We hide all those arguments for a reason. I can right-click again and say hide them. And if I'm doing some kind of really hairy metaprogramming, or if I'm trying to debug the compiler, then I may want to see what it looks like in the core language, and here I can see that. Question? It takes a very long time. So what happens in practice is you get really bored and then you kill Idris and then reload it. I could have we do totality check things, so I could put a safety valve on there and ask for confirmation first. That might be a good UI improvement here. But the Emacs Lisp is not the key thing here. The key is the Haskell code behind it that makes it work. And so this is great in a REPL. But sometimes I also want to actually, use some real code. So here I've got a really stupid little expression language where the nat that indexes it is just the number of free variables. I've got a type synonym here, which is program, which is to say that programs are closed terms. I've got a little evaluator, which does everything you'd expect. Clearly, it has the partial annotation because I can write this program omega, which, when interpreted, will take a very, very long time to run. And then I can write a function called run, which is eval specialized for programs, which is to say for closed terms, and it supplies the empty initial environment for the execution. And then I can define an open term, which is, here we have a term with 2 free variables, one of which is used here. It's adding 2 to something that's sort of 2 round indices up. And if I then uncomment my definition of mistake, I get back this type error. And I see that I've got a type mismatch between expr of 2 and program. Specifically, it's a mismatch between 2 and 0. If I didn't know how this library is implemented or how this little interpreter is implemented, I'd be really confused right now. Like, wait, where is that 0 coming from? What do these have to do with each other? And so what I do is I move my mouse up to this term here, I right-click it, and I say normalize it, and then the connection becomes much, much more clear. And I think this would also be a very nice thing to have in GHC. If I get a type error with some type synonyms, I could sort of expand them in place without having to do a bunch of things to figure out what's going on. And over here it says this is the type of open term. Maybe I've forgotten what open term actually was. So here I can also right-click and I can say normalize it, and then I've got a much better idea of why it has the type term 2, because it's got this variable here pointing upward, which is unfortunately line breaking with this font size. So
Can we click on the 2 to see where it came from? Not that 2.
this one?
Yeah.
No. So in general, it's so the reason I don't have a good way to do that right here is because what it's giving you back in type mismatch errors is the portion of the type that didn't match.
But it came from top.
It did.
Right?
So we've got a source location up here, which is the location that the error was thrown from. These error messages could be nicer, but regardless of how nice your error message text is, I think it's useful to be able to interact with them in any case. Okay. So that's just a little demo of the kinds of things we can do in Idris today that I love to be able to do when I'm actually working on Idris. So the way this works is that we have a pretty printing library that supports semantic annotations, which is to say that the pretty printing document is annotated by little bits of data that describe the meaning of the sub-documents. So if I pretty print a term, I annotate it with the actual term that I pretty printed. If I pretty print a name inside of that term, I say it was this exact name, and then I don't need to sort of include the full path to the name in order to get disambiguation, because the entire object is actually there. Then the library provides both in-band and out-of-band communication of these annotations. So that's very important when I'm wanting to work in both console and Emacs and that kind of thing. I can specialize the use of the rendered document to both places. And then we have various commands at the REPL that take annotation objects in a particular serialization as their arguments. So when I'm looking up the documentation for some name that's overloaded, I get that exact one, and the fully qualified name is what's being sent under the hood to the thing to ask me the type or the definition. Or when I normalize a term, I send back a base 64 encoding of terms binary instances combined.
What about these DOS components, which I didn't understand?
Yeah. Yeah.
So it doesn't matter that I don't understand what they do yet.
I'm getting in. Yeah. So this is like a summary of the slides to come. So what I'm going to present here is a recipe for how you build this yourself, because everybody has their own pretty printing library, and I don't think that one is going to work for everybody. So you start with the pretty printing library. Certainly the sort of John Hughes, Simon P.J. style or the Wadler Lyon style will work. I think concretely the things that we actually need in a pretty printer library for this recipe to apply are we need a sort of a type doc or document, which is representing a set of strings to be determined by the actual context in which they are rendered, or specifically the width at which they are rendered. Some combinators for constructing a doc, so we can make docs out of string snippets and We can stick them next to each other. In some of these APIs, we can stick them on top of each other. Then we have renderers that convert a doc into a string or write it to some file handle like standard output or an actual file. In the meantime, there may be some other thing like simple doc in the Waterline pretty printer, but that doesn't matter for here. And then we take this pretty printing library and make it actually say what it means, right? So we add a type parameter to doc, which is the type of annotations of subdocuments. So now instead of doc, we've got doc A. And we add this new operator, annotate, which takes some annotation and a document that can accept that annotation and gives back an annotated document with the appropriate type. And finally, the API needs to be extended with some output methods. So one of them should be output spans, which is going to take a document with annotations A, and it returns a pair of an output string, and in this case, a list of offset length annotation triples.
Is this a version of render? It doesn't render, so you have to tell
Yeah,
it how to write it.
so in the particular API of the one used in Idris, that's a separate step that makes a simple doc, and then that goes in here because it's using WLP print as a base. But yeah, so whatever your rendering stuff is, make a version that outputs these. And then we may also want to have another one where we communicate in-band. And the in-band, so this is, the output spans is a kind of out-of-band communication. We're saying these subregions of this string mean this. Whereas display decorated takes a method for transforming substrings based on their annotations of the documents that produce them. And it then takes a document and gives back a string. So for example, we might use display decorated if we want to wrap ANSI escape codes for colors surrounding names, depending on what kind of name they are. Or we might want to use it to wrap HTML or LaTeX around it if we want to make writing papers or web pages easier. And this is all well and good, but actually it leaves out something very important, which is the desktop operating system used by almost everybody on the planet, which is Microsoft Windows, where those two operators are not sufficient to do console colors, because on Windows you actually need to run an IO action to change the color rather than simply dumping in this escape sequence. So obviously this works. Here's a screenshot of Idris on Windows. So the way we do that is we then have a slightly more general display, which it takes a means of displaying a particular sort of ground string from the document. Then it takes, for a given annotation, what to do when that annotation begins and what to do when the annotation ends. And then it takes a document, and then it's returning f of b. So for doing output on Windows at the console, we let f be IO and let b be unit. And so we're not really caring about the monoid side, but if we're wanting to accumulate an output string, then that's useful. This isn't enough to implement everything. If source span information was added to the start and end effects, then it would be actually general enough to express all of the signaling of annotations. A very important point is that doc is a functor. So the key reason why we need this is that we can then transform and decorate annotations after we've stuck them on a document. And this has a lot of uses, more than I initially thought when I just thought, oh, I better put a functor instance on it. So one is that it lets us have a lot more decoupling between the pretty printer and the rest of the compiler, because we don't need to have all of the information about every name. So if we want a pretty printed term, we don't need to have its doc string around in order to stick the doc string in the annotation. We just need to know what the actual name for, what the actual fully qualified name was. And then later we can have a separate pass when we have documentation available, where we go through and change the annotations from bare names to, a name, types annotation, and docstring triple. It also lets us have sort of decoupling between different areas. If one part of the compiler is producing documents with one kind of information, we can then use this to translate it into the annotations used in another one, or put them under a constructor or something like that. It's also used to convert annotations to the protocol used for IDEs like Atom and Emacs under the hood. So there we throw out all of the things that Emacs doesn't get out of the document, out of the annotations, and we base 64 encode the terms and these kind of things. And finally, it's even useful for things like running the type checker on example terms that occur inside of the Idris equivalent of Haddock. And then we can, inside of Emacs, if you look up the docs for something, you can see this term contains a type error and mouse over it and get get that as a tooltip if you're wanting to demonstrate the kinds of errors your library prevents, or you can see the results of evaluating a term inside the docs if it does type check, which is kind of a nice feature to have as well. There's two implementations already that I know of if you want to get going with this. There's annotated WLP print, which is the one I hacked together on the train commuting between Copenhagen and Gothenburg for a while. And this is the one used in Idris. It's a Waht Lion style. And then the Pretty library. So I did an internship with Galois last year, and Trevor Elliott thought this was a cool idea. So he wanted to put this on Pretty. So if you're using Pretty, you already have annotations available. Just change your imports. And this one has an API much more like the one we have from GHC, which would be kind of nice. And then there's also Edward Kmet's WLP print extras, but this is exactly, yeah. Someone asked me on Reddit what the difference between these were, and so I had to go look it up and learn about it because I actually wasn't aware of it when I was looking around. And so this one, you actually are sticking effect objects inside of your document, which is another valid, interesting approach.
And if Florida just reached out to me to ask if I'd be willing to add the other parameters, so
Yeah.
I can have your thing as the first argument, and then
Yeah.
this would be the second, so that we would remain mode add all the things that.
That would be handy too.
So,
Yeah, I mean, I think annotations are really useful. So, okay, and so just to sort of wrap up, the first thing is that like if I got a little bit of an ideological program here. So when pretty printers actually tell you what they mean, rather than simply saying something to you, then you don't need to guess. You know exactly what they are, and this enables a lot of really nice interaction possibilities with our development tools. Even worse, we might have to parse something. That's really horrible. So editor commands are able to get a hold of references absolutely directly. We can implement this in a sort of incremental manner if we want. Just export, type doc is the annotated doc with trivial annotations. And as sort of a final point, I think it's really important that we not forget all the cool stuff that's happened outside of our own silo. In the Lisp and Smalltalk world, they've made amazing development tools, especially when it comes to like inspecting libraries and understanding code and interacting with them. I think we can take these things that they've done and make them even better by having a really nice, strong type system on top of it. So thanks for listening. And yeah.
I'm interested in the type of annotation because if you add various annotation to it, the type should be regular, subtype, or product type, but that would be
Yeah.
difficult to control.
Do you want to see the one in Idris?
Yes.
Yeah. Is this still legible if I make it a little bit smaller? Okay. There. So we've got names, which consist of an underlying name and then some extra stuff that gets filled in later. And that's for sort of global references. We got bound names and whether or not they're implicit. We've got constants, which are underlying constants from the core theory, like strings or ints or whatever. We've got that.
If you want to do like that, a new feature, you have to add just some type. There is an expression for it.
Yeah, I mean, you can also wrap it inside of the constructor of another type, right? So one thing I've actually been meaning to do for a while is refactor this a bit so that the annotations used in different areas of Idris each have their own type and then just wrap them in a constructor. But it gets transformed to various things at various points. So inside of the IDE thing, we've got,
One transformation requires one thing, they discard all the other.
yeah.
Right?
It's what?
If one interpreter of annotation needs some part, only some part of the interpreter,
Yeah,
they disregard all the other constructors.
yeah,
So that in that sense, it's expensive.
yeah.
If there's time, I'd love to see just feel like we map that to something structured that's that Emacs is going to look at.
actual function is really ugly, actually. It's, yeah. Where is it? Yeah, here it is.
Okay, so a person who believed in types might choose to do something a little more elaborate.
Definitely. I mean, this is very much like spare time activity by a couple of bored PhD students. I mean, it's not like we've sat down and made it totally awesome. And then the communication between Idris and Emacs is looking kind of like this for the things that I was doing with the error messages. So, you know, we're getting back a string and then some offset length annotation triples encoded as S expressions. And then here's the actual term represented in the error message, which is kind of, this may not scale, but so far it's so far it's been okay. It's base 64 encoded, so we could definitely switch to a different encoding, but the right libraries weren't on a hackage, and this is good enough. So from the perspective of Emacs, this is just an opaque token representing the term that it can use for Idris. And I could also store things in a hash map inside of Idris and give them IDs and send the IDs to Emacs, but there's no point, right? I mean, and you know, now I can restart the compiler and not lose my state and that kind of
It
thing.
would be nice to have the structure of this stuff expressed in static type system.
Yeah, and it is, except when we come to output it.
Right.
Yeah. And here, I mean, our main clients right now are Emacs and Atom, so those don't exactly have strong static type systems for I/O. But yeah, there's total room for improvement.